Now we are going to implement the two major operations for the queue, how to add the data onto the queue called the push, how to remove called the pop. For push, we are going to do something like this. So in this queue, we could do push and the 10. Then at this moment, queue should not be empty. Then since I added the one data, length of the queue should be 1. And then similarly, if I add another data, still queue is not empty, and then length of the queue should be 2. But in implementing a push function, we need to consider a few other things. So here we are going to add a void push, and the integer data will be pushed onto. Then in implementation file, so we are going to do push function integer data onto the queue. So here in implementing push, a few things we need to consider. First, we are talking about the circular array. So as we allocate an array, we assume it's just something like this circular, and then those are elements. Then let's assume that this is index 0, 1, 2, 3, 4, 5, 6. Then capacity of this queue or length capacity of this queue is 7, since it's 7 elements. So as you do first push, that will be stored here, and the second push, and another push, and another push, and so on. So push operation is we need to know which one is the back of the waiting queue. Assume this is waiting queue, then 40 is the back of the waiting queue. So push means you need to push data after the last data back of the one. So to do so, we need to remember which index is currently the back of the queue. So let's define a variable named I back, index of a back. So at this moment, the index of a back is a 3. So when you do push, what I need to do is increment I back. Then it becomes a 4. Then onto the I back index. So array is a P array. So index of I back. Now I can store new data there. That's the basic idea of the push operation. So if you write the code for that, so basically push operation will be, so increment I back, and then onto array at I back location we are going to store data. But to do so, we need to do a few things to take care of. First, the variable I back needs to be defined. So here integer index I back is defined. Second, what would be the initial value of I back? So initially the array is empty. Initially the array is empty. As you do push, we increment I back and then we store the data. So if currently there is an empty queue, then I back should be 1 less than I0, so that when you do push, as it's incremented, I back should be the first index 0. So based on that, we can guess or reason that the value of I back, let me break the line here, break this one for readability, value of I back would be -1 to begin with, when queue is just created with no data at all. Then when you do first push, I back is incremented, then it's stored at index 0. But if I back is a certain number, it will be incremented and so on. Then as you do push, also we need to maintain that count of the queue is properly maintained to increment that. Another one we need to consider is since we are assuming a circular queue, so we cannot blindly increment the I back. When the I back is at the last index, then if you increment I back should be 0. So we need to maintain the circular one. So what you could simply do is as we increment I back, if now I back is same as a capacity, which means I back is past the last index. So last index is always one less capacity. So after increment, the I back is capacity means it's past the last index. So then we would reset I back. But since this operation, incrementing I back, may be used frequently, so we could make a function for that. But this function is not for other users. It's not for users of a fqueue class, but just internal implementation. Then such a function you could place as a private member function. So here, void increment I back function. Let's define that. So member variable is incremented, so it cannot be a constant. Then here we could define void fqueue increment I back. There what I do is increment I back. If I back is the same as capacity now, then let's reset I back. So let's define increment I back as a function. Then you could simply call increment I back function here. It's a private internal function only. So the push function is implemented. So let's test up to here. Compile the code and run it. Then the main function we had so far is the testing, just two pushes and then testing length functions. So, but we don't verify yet whether the pushes properly store the data, but it could be verified when we implement the pop function. So here, now let's add the pop function. So pop function is simply to remove the data, but to read what is at the front of the queue, we are going to give two more operations. So into data, let's read what's on the front. Similarly, we could read what is on the back, but the back function is not the primary required operation of the queue. So queue, we are always interested in what is on the front, which is the first to enter the data, but just without any further cost, we can easily read what is on the back as well. So here, to read what is on the front, so we need to maintain another index that front. So where is the first data front? So at the very beginning, front is always 0. Initialize that since the first data entered will be at 0. So front will be at 0 as initial value. Then implementation, what is on the front is return p array I front. That's the data on the front of the queue. Similarly, what's the value on the back of the queue? Since we maintain I back indexer, so we can simply read from there. Here we want to assert some condition for push is that if queue is full, we cannot push it, so it should not be full. That's the assertion requirement. So before you push it, make sure that it's not full. So front and the back we can read this way. So if we update our main program for that, now let me clear up the screen for drawing. So we can do some front and back test. So we have added a 10, then assert that Q front and then Q back should be the same since this is the only data. We should we cannot cascade the equal sign, equality sign, so check those two are the same, then check if front is 10, could do that. Then as I add one more, front is still 10, back is now 20. So we can verify up to here. Assert full, the assert is not declared. fqueue is that. So here in the queue implementation, we have used assert function on the push it, but assert function is on C assert library. So we need to include that. So let's compile again. Runs and the front end queue is verified. Now we are ready to implement the pop function. So pop function, let's implement that. So void pop is so pop means if I draw the picture again, so here is a circular array with a certain capacity, index 0, 1, 2, 3, 4, 5, 6, like that. So we maintain two variables, front index and then back index. So if I have a data something like this, front index is 0, back index is 3. For push, we incremented the I back, but for pop, we are going to remove this data, means we need to increment I front. That is a pop operation. So in pop operation, we are going to increment I front. Then virtually the data is removed. We don't have to physically take the data out. It's simply just incrementing the index. Then that should be it. Then we need to maintain the count, the number of data that. Again, since we are using a circular array, you cannot blindly increment I front to any, so we need to take care of those circular array situations. So we are going to have a private function called inc I front, similar to inc I back. So here in private member, we are going to add inc I front function. And then inc I front function will be very similar to inc I back. So let's copy those inc I back function and change it to I front. Then the I front is incremented. If I front is the same as capacity, then I need to reset I front. So that's inc ifront function. So pop is simply increment the ifront in circular array and then decrement the number of data there. Of course, so we need to assert that to do the pop, it should not be empty. If it's empty, pop is meaningless. So let's go back to test code for that. Now we are ready to do some pop operation. So before that, let's do push one more time, 3 of those. Then at this moment, front and the back. Front is still 10, back should be 30. But if I do pop, front 10 is removed, so 20 is now become front. The back should be 30. And then if I do pop again, now front is 30 and then back is 30. At this moment, length of the queue should be only one data left over. And then if I do pop one more time, then length of the queue should be 0. So let's test up to here. So all tests are successfully done. So we have implemented the major operations needed for queue data structures.